You know, where in GF strong was it if you don't know the auditorium, etc., etc. So most of our locomotion is performed at this automatic level so that we can think about other aspects. But locomotion does take place in an unpredictable environment, and therefore we do need this skill to adapt that rhythmical quality of locomotion to get up the stairs or get around the environment. And I'll deepen that for you. So to look at the neural control underpinning locomotion, I want you to have these questions or think about these questions for yourself. So currently, what's your paradigm as a therapist? What's your understanding in terms of what's your understanding first, but what are your current tools that you use on a day-to-day basis when you've got the patient in front of you to influence their movement? How much of your influence is verbal? And if it's verbal, what sort of verbal information do you give? Do you tend to be someone that throws a lot of instructions? I want you to lift your leg, straighten your knee, I want you to pick up your foot, I want you to bend your hip, etc., etc. Or do you provide goals? I want you to move and get that shoe for me over there, or go get a drink for yourself. Or do you have another way of speaking? How often do you use somatosensation? How often do you influence movement by muscle, joint, and cutaneous input? What do you think about in terms of the environment? Do you ask the question, how is the visual information that this patient's receiving influencing their ability to walk? Are they walking in an environment that they know or they don't know? Is it familiar or not? Because that will make a difference in terms of how the central nervous system creates walking. Is it an open or closed environment? Are there other patients walking in relationship to them as they walk, which requires another skill beyond a closed environment? And the other major question I want you to ask yourself in this first section is, do you believe that muscles are activated on an individual basis or as part of a multi-joint pattern co-activation? Right? So if your goal, you've clinically reasoned that you feel the reason that the patient's got a lot of difficulties with their walking is weak quadriceps, for example, and you're going to plan a treatment, whether that be in the stroke patient or the orthopedic patient, to strengthen that, do you perceive that you need to focus on the one muscle, that the central nervous system speaks specifically to one muscle, or is that muscle always in a patterned activation? So they're the questions that these next sort of 15 minutes I'm going to give you some information to influence your answers to these. So going back to categories of movement. So all these categories exist. They're not that one is right and one is wrong. Reflexes is that which we have had traditionally. So Sherrington, you know, back in the early 19th century, presented the knowledge about reflexes, and again it was gained by taking animals and killing them and disconnecting the spinal cord from the higher centers, so classically a brainstem lesion, and then looking at what happened in the spinal cord, right? And they found, as exists, reflexes. Right? Probably the most well-known is the monosynaptic stretch reflex, but there are many, many reflexes that occur at a spinal cord level. Now, the contemporary view is that they exist, right? However, when the central nervous system is connected to the spinal cord and it hasn't been chopped and the animal being killed, in fact, the reflexes are integrated with commands that are centrally generated to produce adaptive movements that are specific to the task. So we have reflexes within us, right? But we aren't reflexive in nature, right? An example is that, let's say you have a hot pot on the stove, right? And you go to pick it up and it's really hot, so that, you know, you're going to get a burn on your hands, right? You, depending on what's in that pot, how full it is, the consequence of spilling it, you can choose to keep hold of that hot pot and not allow the flexion withdrawal to dominate, right? Or you can allow the central nervous system, the higher centers can choose to allow the reflex to predominate. Right? So reflexes exist. Reflexes are a part of locomotion, but they are integrated by centrally generated commands. We have rhythmic activity, so repetitive rhythmical motor patterns, of which the locomotion, the pattern between the two legs, the flexion extension, is rhythmical repetitive motor patterns. And that circuitry I'm going to get into a lot more when we look at central pattern generators and a little bit later. And then, of course, we have voluntary movement. So voluntary movement, which is another component of, or locomotion is also, voluntary movement is a part of locomotion. It's performed to achieve a goal, right? So we typically locomote because we have a goal. That goal may occur because of an external stimuli or an internal stimuli, right? So you may see a friend and you want to walk over to meet them, or you might see a friend and actually want to walk the other way. So you have external stimuli that provokes the goal of locomotion, right? Context-based. You might be sitting here at the moment thinking, okay, having an internal stimuli of a rumbling stomach, thinking, oh, you know, I rushed from work, I didn't get dinner. I wish I could get up and go out and get my meal, right? Or the stretch of the bladder wall, right? I'd rather be going to the washroom than sitting here listening to a lecture. It's an internal stimuli that demands to fulfill a goal and locomote. Voluntary movements are also based, this is an important sentence here, they're based on an internal representation of the state of the body, so body schema. Now the term body schema has been sort of a popular, it's come into neurology, I'd say, in the last decade or so, and it's considered to be, this internal representation of the state of the body is considered to be a very important component in terms of the evolvement of the next movement. So that's a body of knowledge that's, or of literature that's relatively new but very important. So if you have a body part that has not moved discretely for some time, then your body schema will have clumped those body parts together. So if you have had a fractured hip and therefore you've walked with not so much hip movement for a period of time, the internal representation of the pelvis and the femur will have been disrupted and clumped as one, maybe also with your lumbar spine. So therefore, from a central nervous system perspective, you can't separate out those pieces. You feed forward to them as a group. The other important thing in terms of voluntary movements that I wanted to point out here is that they require integration of visual, proprioceptive, and postural information. So, how many of you are familiar with this homunculus picture? Yeah? Okay, so I'm going to ask, how many of you have a belief that, you know, we all learnt the homunculus, that what this means is that there is a place in the brain where, let's say, the shoulder, no, let's go for the elbow, right, is represented, and that means that a neuron from that cortex speaks to the elbow to produce isolated elbow movement. How many for you is that the sort of rationale or the clinical representation of the homunculus? Because if it is, that is what we were taught, right? That is what we were taught. That is what was believed, right? It came from experiments where they put electrons on the cortex and they triggered a part of the cortex and saw what body part moved. And when you do that, yes, these body parts move. But in the context of movement, right, we now know absolutely categorically that there is not a cortical neuron that represents the elbow that is wholly and solely responsible for movement of that one body part, right? Instead, as is written in the text there, the motor cortex has this mosaic of representation. So